Number 14, graph the solution of negative 5a plus 6 is greater than 11. Go ahead and write that inequality down on your paper. It's hard to solve an equation or an inequality if you don't already have it on your paper. Solving an inequality uses the same steps as solving an equation. And the first step is always to simplify both sides. That means if there's parentheses, you have to distribute. Remember, we did a problem like that yesterday, was with an expression, not an equation or an inequality. Combining like terms is another way you can simplify. We don't have any like terms that we can combine on the left side or the right side. So after all that's done, and it's already done, the second step is to separate your variable term and your constant term. Your variable term is the term that has the variable next to it. So this whole negative 5a is our variable term. We have two constant terms, one on each side, and our goal is to get those constant terms on the same side. So you've got a variable term on one side and a variable term or a constant term on the other. To get rid of the plus 6, what do you have to do to both sides? Parker? Minus 6 on both sides, that's right. Parker, what is 11 minus 6? 5. So now we have negative 5a is greater than 5. Now we have the variable term on one side and our new constant, which is the combination of a negative 6 and an 11 on the other side. Now, this whole thing is the variable term. And so that number that's squeezed next to it is called a coefficient, not a constant, but a coefficient. The number can be squeezed next to it like this to show that it's being multiplied, or it can look like this, can be written underneath of it to show that it's doing what? Dividing. Yes. So the number you're either multiplying or dividing your variable by is called the coefficient. Our negative 5 in this problem is being multiplied to the a. And what's the opposite of multiplying by negative 5, Natalie? Dividing by negative 5. So we divide both sides by negative 5. Natalie, what is 5 divided by negative 5? Not minus. What's 5 divided by negative 5? Think 5 divided by 5. Okay. And then think how many negative numbers are there? 1 or 2? Just one. So negative 1. Yeah. So negative 1. Okay. So there's something else we have to do. There is an extra step that you sometimes have to do with an inequality that you don't ever have to do with an equation. And it comes down to this last step where you're multiplying or dividing by a negative number. Do you remember this extra step you have to do in an inequality? Think about what's different about an inequality. Hannah? That's exactly right. You have to flip the sign when you're multiplying or dividing an inequality by a negative number. So now this is going to say a is less than negative 1 instead of a is greater than. By the way, that's going to shade the entire direction or change the entire direction we're shading. Okay. So the reason for that, and I feel like this is the easiest way to explain this. Do you all agree with that statement? Mm-hmm. Of course you do. Okay. Well, if I times both of those numbers by 2, do you still agree that 4 is less than 6? Yeah. Okay, still true. What if you times both sides by negative 2? You'll get negative 4 is less than negative 6. Do you agree with that? No. That's wrong. Negative 4 is actually larger than negative 6. And the reason is because as numbers get more negative, they get less in value. Whereas on the positive side of the number line, as they get more positive, they get higher in value. So in order to make this true, I have to do one thing. And you could say flip the numbers around. I guess that would work. Or you could just flip the sign around. And that's exactly why when we divide both sides of this inequality by negative 5, we have to flip the sign. Now remember, you only have to flip the sign when you're multiplying or dividing by a negative. If you're multiplying or dividing by a positive, as you just said, 4 is still less than 6, nothing has to change. It's only when you divide by the negative or multiply by the negative that you'd have to flip the sign. So keep that in mind. That's the only thing that makes an inequality different from an equation. That and the fact that they're going to ask you to graph it. If they ask you to graph an equation, you know what you'd put? If your answer was x equals negative 1, you'd put a dot right there at negative 1. That's no fun. But for an inequality, it's everything that's less than negative 1. So there's more to shade. Now, can a be equal to negative 1? No, there is not an equal bar underneath of it. So I do not want to shade in the -1. We call that an open circle. So the only 4 options that I'm actually looking at here on this one, I want to ignore the ones that have the closed circle, because that would say that A could be equal to -1, and that's not true. Now, so I'm going to use an open circle around -1. And what direction of the number line would I shade if A is less than -1, Frank? To the left. So I'm going to choose the arrow pointing to the left. By the way, you do not need to draw the number line on your paper. I haven't made you do that all year long. Make sure you've got your work on your paper and your answer. And then on big ideas, you can shade it. Okay, so we're going to shade to the left with an open circle around -1, and you'll find -1 between these two numbers, -2 and 0. So we're going to shade that to the left like that. Questions? All right, let's move on to number 15. Number 15, tell whether 20/8 and 28/9 form a proportion. Well, if they do form a proportion, what symbol do you put between the two ratios of a proportion? An equal sign. That means that if they do form a proportion, they are going to be equal. Now, there are several different ways you can check to see if they're going to be equal. What's one of them? Lucas? That's right. That's going to turn them into decimals. And so I'm expecting to get the same answer. Lucas, will you do 20 divided by 8 while Whitney does 28 divided by 9? And tell me what you get for your decimals. Go ahead. Whitney, what did you get? 3.1 repeating. Okay. 2.5, 2.5. Yeah, that's right, 2.5. Okay, and those aren't equal. So you can tell they're not proportional. That's one way you can tell. What's another way you can tell? And we don't have to list them all, but what's the other? I mean, we don't have to, shouldn't say we are going to list them. We're not going to do them all, but what's another way you can tell? You've already told me one. Frank. I mean, you could turn the decimals into percents, I guess, but that's essentially what we already have. Okay. Sierra? Exactly. You could cross multiply like you guys have been doing. Remember, when you cross multiply, usually there's an X. And so we say that this X, 12X is equal to whatever else it is, right? And I know that cross products are supposed to be equal. So we're not solving for X here, but I can still see if they're going to be proportional by seeing if their cross products are truly equal to each other. Sierra, excuse me. Sierra, can you tell me what 8 times 28 is? And Lainey, will you tell me what 20 times 9 is? You got 224. Okay, Lainey, what about 20 times 9? 180. Again, not equal. They're supposed to be equal if they're proportional. The other way is nobody's favorite. It's reducing the fractions to see if you get the same. 28/9 doesn't reduce. 20/8 does reduce by 4 to get 5/2. They're not the same. By the way, 5/2 is the same as 2.5. So I'm a fan of just using the decimals at that point. So yeah, however you like to do it, you can tell that these are clearly not proportional. All right, number 16. The graph shows the numbers of miles that 2 cars are traveling. Car A is in blue, car B is in green. Car B travels blank more miles than car A each hour. When you graph distance over time, what does that actually give you? What is distance over time? You guys learned this in science class. Put the bottle down or I'm going to take it. Velocity, okay, that's true. Velocity also tells you what direction you're going, whereas we wouldn't necessarily know the direction of these cars. So what do you call velocity without direction? Ella? Not acceleration. Speed. I'm hearing you say just speed. Yeah, just speed. Okay, which is velocity would tell you if you're going up or down or what direction you're going, whereas speed just tells you the quick. Velocity also tells you how fast you're going, tells you the speed. But we're not going to get that from these cars. I don't know what direction they're going. I assume they're going not up or down, straight probably. But anyways, yeah, you can see the speed. Distance over time equals speed. So these arrows here, these lines, show the speed of the two cars. Can you tell which car is traveling faster? Car B. Why do you think it's traveling faster? Their line is steeper. What do you call the steepness of a line? Jude? The slope. That's exactly right. Do you remember doing slope? Rise over run. In this problem, rise over run is going to be distance over speed, because the rise is the y-axis and the run is the x-axis. Or not distance over speed, I apologize, distance over time, okay, which is speed, okay? So the green car is going faster, and we're supposed to figure out how much faster it's going. Now, when you have a line, or in this case, two of them, and those lines travel through the origin, those lines are special lines called direct variations, also called proportional relationships. More on that in a moment. They're called direct variations. And that makes sense here, because if the car doesn't travel for any length of time, it's not going to go any miles. So it makes sense it would start at 0, 0. It says, how many more miles does it travel each hour? Now, I want you to notice the word hour is singular. What do you call this rate that has a unit of 1 on the bottom of it? A unit rate, exactly. And so if my line is a direct variation, I can find its unit rate just by looking for the number 1 on the x-axis. Isn't that 1 hour? Miles per hour is our unit rate. For car A, and that's the blue one, how many miles does it travel? I'll just draw that line all the way through. How many miles does car A travel in 1 hour, Natalie? 40. That means car A's speed is 40 miles per hour. I know you're thinking it's rocket science. It's not. Well, it's nothing special. What about car B? How many miles does it travel in 1 hour, Branson? 50. Car B is traveling 50 miles per hour. If you know how far a car travels in 1 hour, you know its speed, because we always do speed in miles per hour. So the question is, car B travels blank more miles than car A each hour. It might as well just be saying how much faster is it going? Addison? 10, yes. So it's traveling 10 miles per hour. If you're wondering to know what work you'd show for that, maybe just put 50 minus 40 equals 10 miles per hour. You can also write miles per hour as mi/h. You'll see that occasionally. Means the same thing, because the word per can be written as a slash. But miles per hour is such a common rate that if you just put mph, everybody knows what that means. What's kph stand for? Kilometers per hour. Okay. When you're traveling outside of the States. They use it in Canada too. It's kind of crazy. It's like you ever wonder when you're going to use the kilometer conversion on your speedometer on your car until you're traveling to the Niagara Falls on the Canadian side, and they're telling you the speed limit is 80 kilometers per hour, and you're trying to figure out what that is. And fortunately, that conversion's on your speedometer. So you know you don't. All right, number 17. Number 17, can you get the door for me, please? Says the graph of a proportional relationship passes through 918 and 1y. Now, these are coordinate points. Now, a proportional relationship is another way of saying a direct variation, which we just said a direct variation looks like this. It's a line that goes through the origin. So I know that these 2 points are going to sit on the same line, and eventually that line would take you through the point 0, 0. So that's what I know. Now I still need to figure out what this y coordinate is of the second point. So this is where the word proportional kicks in. Every point on a direct variation is proportional to all the other points on that same direct variation. For example, look at the blue car. The blue car travels 20 miles in 30 minutes. Is that the same as traveling 40 miles in 60 minutes? Exactly, because that's 1 hour, right? So all the points on the line are proportional to the other points on the line. And that's exactly how we're going to find out what y is. Because if these 2 points sit on a proportional relationship, aka a direct variation, that means that the point 918, if you write it as a ratio, is going to be proportional to what? 1 over y. That's right. Cross multiply, what's 9 times y? 9y. What's 18 times 1? And 18 divided by 9 is 2.
And as each kid receives a card, initial, can I get that back to you?
Perfect. Yeah, we can do that.
Thank you.
All right, number 18. A person walks 1/4 of a mile in 1/8 of an hour. This reminds me of some of the iLearn practice problems we looked at a few weeks ago. The person's speed, remember, speed is distance over time. Did you notice they gave us distance and time in this problem? Okay, is miles per hour, or sorry, is blank miles per hour. So miles per hour is what kind of rate? Miles per hour. It's a unit rate. That second label is singular. That's right. Oh my goodness. Hello? Okay, so this is a unit rate. How do you find a unit rate? How do you find a unit rate? If I told you we were traveling 500 miles and it took us 12 hours to do that, how would you find the speed? How would you find that unit rate, Aiden? Divide. You divide. Is it coincidence that speed is distance divided by time? No, that's not a coincidence. That's how you find any unit rate. You divide. It just happens to be that speed is a unit rate miles per hour. So we're going to divide this. And it tells you what order to divide it in. Even if you didn't know that speed was distance over time, which is the order we're going to divide it in, the word per can also be a slash or division symbol, and that tells you to do miles divided by hours. So 1/4 miles divided by 1/8 hours. Now, typically, I try to avoid fractions within fractions. They're called complex fractions, and as you might assume, they're complex, exactly. But remember that this middle division fraction bar is just a division sign, and that means we're just going to divide these fractions. Now, how do you divide fractions? We did this yesterday. You multiply, you just change it to multiply, or do you just do anything else? Flip the second fraction, exactly. We call that keep, change, flip. So keep, change, and then that second fraction, the one you're dividing by, gets flipped. Maddie in says, what is this going to be as a multiplication problem? Perfect. Remember, we call that a reciprocal. Good. And Maddie, does anything cancel here? What cancels into both of those? Okay, 4 goes into 4 once, and 4 goes into 8 how many times? 2. All right, so that's going to give us 1 times 2, which is 2, over 1 times 1, which is 1. And what is that the same as? 2. And then, of course, once I divide my numbers, I also have to divide my labels. Miles divided by hours, we would just say miles per hour. So the answer is 2 miles per hour. If you walk 1/4 of a mile in 1/8 of an hour, that means you are walking 2 miles per hour. Number 19, complete the steps for drawing a triangle with a 2 centimeter side, a 6 centimeter side, and they meet at an 80-degree angle. So we're not actually going to draw the triangle, but we're going to describe the steps to that. It says use a blank to draw an 80-degree angle. What do you call the tool that allows you to draw and measure angles, Natalie? It's a protractor. That's right. Remember, the protractors are those semicircular looking tools where you can measure. We actually used it earlier this year to measure an angle. You can also use a protractor to draw an angle. The way that you do that is you need to draw a straight edge using the bottom side of your protractor. You then count up to 80 degrees and put a dot, and then you slide your protractor so the straight edge is now connecting that dot with the end of your line that you just drew, and you can draw that 80-degree angle. It's pretty simple to do. Okay. Now, we need to make sure that we not only have the 80-degree angle, but we have the right side lengths. So Frank, what do you call the tool that allows you to measure a 2 centimeter side and a 6 centimeter side? A ruler. Yeah, a ruler. So we'll also need a ruler. Some protractors have a ruler, tiny ruler at the bottom, and they also have like the 0 to 180 degrees on the top side of it. So you can actually measure the length of the ray that you're drawing. Two rays make an angle. Now, so far we've got an angle. We don't have a triangle. So what do we have to do to make the triangle? Once we have the 2 centimeter and the 6 centimeter and we know they're 80 degrees, we just draw that third line. Connect the two sides that need to be connected, and you've got the triangle. Okay. Bonus question for number 19. How many triangles? Well, yes. How many triangles can you draw with the descriptions that you've been given? Can you draw one unique triangle, more than one, so many triangles, or no triangle at all? Addison, why do you know that it's unique? How do you know that it's unique? That's right. Nice job. They gave you the side, one of the sides, 2 centimeters. They gave you another side, 6 centimeters, and then they told you that they meet at an 80-degree angle. And so when they give you the side, the angle, and then a side, that is a sassy triangle, and that is one of our descriptions of a unique triangle. That means that if I said, okay, I need everybody to draw this triangle, if I go around and look at all your triangles, they will look exactly the same. There will be no two triangles that are different, because you can't make your triangle look any different if I told you it has to be 80 degrees. You can't make that third side any longer, because that means you'd have to widen that angle. You can't do that. You can't make these sides any shorter or longer, because they're already, 2 centimeters and 6 centimeters. I've already told you those sides. So this would be unique. That's right. If I take one of those things away, all your triangles will look different. But with all three of those descriptions, this would be a sassy triangle, one of our most famous unique types of triangles. Can you give me an example of when I would give you side lengths or angles that don't form a triangle? Or the answer would be no triangle. There's only 2 reasons you could have no triangle at all. What's one of them, Lucas? That's right. When the 2 small sides of a triangle, the 2 shorter sides, don't add up to be larger than the longest side. Right, Thomas? The longest side can't be too long, or you're just stuck with flippers. Right? So the 2 short sides have to add up to be longer. And if they don't, as Lucas is saying, you don't have a triangle. What else would make no triangle? What else is true about all triangles? Say it, Aiden. They add up to 180 degrees. If I gave you 3 angles and those 3 angles didn't add up to 180 degrees, are you getting a triangle? No, you're not. Okay. Those are the only 2 reasons that you wouldn't be able to form a triangle. And those are 2 pretty important reasons. All right, number 20. A scale drawing of a square has a side length of 9 centimeters. The drawing has a scale of 1 centimeter to 8 feet. Find the actual perimeter and the actual area of the square. Now, finding the perimeter and area of a square is pretty simple, but we are not finding the perimeter and area of this square. That's the scale drawing. We're supposed to find the actual perimeter and area of the real square. Now, what do we know about the side lengths on a square? They're all the same. Okay, so we know that going in, but this is not the square that I'm finding the perimeter of. The square I'm finding the perimeter of is much, 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 much bigger. I know that because it says that every centimeter on the scale square is 8 feet in real life. So if I have a side that's 9 centimeters, how many feet does that make it, Addison? 72. You get that by just multiplying by 8. Every centimeter is 8 feet. I got 9 of them. You could also set up a proportion. That ratio of 1 centimeter to 8 feet could also be written as a fraction. And so you could say if 1 centimeter is 8 feet, then I got 9 of them. That's X feet. And so that would give you X equals, and literally, if you cross multiply that, you get X equals 72 feet. So if you weren't sure on how she did that, she just times by 9. That's essentially all we're doing here. So the perimeter and area of the square that we're doing is much larger. In fact, that's even too small. If that's 9 centimeters, there's no way that this is 72 feet. Right? But let's just imagine that it is. My big square is 72 feet. I need to know the perimeter of it. Now, the perimeter means I'm adding up all the sides on an object that go around the object. But there's a shortcut on a square. What can you do? What's the shortest amount of work that you'd have to do, Branson? just multiply by 4. As you guys already said, squares have 4 equal sides. So Branson, what is 72 times 4? Okay, so your answer for part A here for the perimeter is 188 feet. Don't forget to label it in feet. If it's just perimeter, it's a distance then. Whereas area is a space. What's the shortest amount of work that I would have to do to find the area of this square? Whitney? I didn't write it down correctly. Sorry. Thank you. 288. Everyone catch that? It's 288 for the perimeter. Okay. What's the shortest amount of work you could do to find the area of the square? Hannah? It involves what type of number? There you go. Not the 9. We're on the big square. The 72. Yeah, so the area of a square is length times width or base times height, just like every other rectangle and parallelogram. But on a square, they're both the same. So you could say 72 times 72 is pretty easy to do, but you could actually say it's even easier just to do 72 squared in your calculator, especially if your calculator has or works with exponents, as all scientific calculators do. By the way, that's what we say, that something being raised to the power of 2 is called squaring it, because you're finding the area of that square. What is 72 squared, Lucas? 5,184. Did I write it down correctly this time? Okay. And then as you can see, it's going to be labeled in feet squared because area is 2-dimensional space and requires feet. Not just regular feet, but feet squared. Number 21. You are recreating a scale drawing of a different scale. The original scale is 1 centimeter to 8 meters. The new scale is 1 centimeter to 2 meters. In the original drawing, the length of the segment is 4 centimeters. How long should that segment be in the new drawing? Okay, so they're going from a scale of 1/8, 1 centimeter to 8 meters, to 1/2, 1 centimeter to 2 meters. Does that mean that this new figure is going to be smaller or larger? Why larger? That's right. 1/2 is bigger than 1/8. Hello? Hey. We'll see. So as Lucas said, 1/8 is smaller than 1/2. And if you don't believe me, just think about how big those fractions would be. 1/8 of a pizza versus 1/2 of a pizza, right? So this is the old scale, 1/8. This is the new scale, 1/2. How many times bigger is the new scale? 4 times. You can fit 4/8 and a half. Did you know 4/8 reduces to 1/2? That's okay. So essentially, by giving us this information, all they're saying is the new object is going to be 4 times bigger. And our object in this case is a 4 centimeter line. So if a 4 centimeter line is going to be 4 times bigger, how long will it be now? 16 centimeters. 4 times 4 is, so this is a 4 times difference, right? So 4 times 4 is 16 centimeters. And I'm okay if you just write that as your work and then 16 centimeters as your answer. If you just write 4 times 4, you're not really going to know what you did. But if you write 1/8 to 1/2 is 4 times more, you'll know exactly what you did. Number 22. Ah, yes. It's been a bit since we've done circumference. It's been a couple months at least, right? Circumference. I love these because if you have the formula, you can do as many circumference or area problems as you want to, as long as you know the formulas. And I'm going to get them to you. Before I write it down though, Frank, do you remember the circumference formula? That's exactly right. Diameter times pi. Some people write it like this. They're not weirdos. They're just writing the equation a different way. What they're reminding you is that if you take the radius and times it by 2, you'll get the diameter. because the diameter is twice as long as the radius is half as long as the diameter, right? And that's actually valuable for a problem like this, because in this problem, are they giving us the radius or diameter? They're giving us the radius. So what this formula tells you to do is to take that radius and times it by 2 so that you can get the diameter and times that by pi. I like just using the pi times d, but you have to remember that the diameter is twice as long as the radius. So what is the diameter in this circle then? 18, okay. And Alexis, can you do 18 times pi? By the way, that's all the work you need to show. I mean, if you want to write down the formula, you can, but you do need to show me what you're multiplying. What is 18 times pi? 56.52. Now, if you're asking me if the pi button will work, I assume it would, but Big Ideas has been kind of sketchy this year with the pi button. I would prefer that we just use 3.14, so we're all getting the same answer, and I know that we're going to get it right versus them. They didn't say we couldn't use the pi button, but we've had problems this year where students have done the pi button and they counted it wrong for some reason. So we'll just use 56.52. It says rounded 2 decimal places, which we only have 2, and we're going to label it in meters because circumference, like perimeter, is just a distance around. Number 23. Number 23, find the area of the circle. Who remembers the area formula for a circle? Whitney? That's right. A equals pi r squared. Now, a lot of mistakes can be made right here because I've seen a lot of students do pi times radius times 2. By the way, if you do pi times radius times 2, you're finding the circumference. So why would a student accidentally do pi times radius times 2 here, Frank? That's right. Squaring it doesn't mean timesing by 2 unless you're squaring 2. Squaring it means timesing it by itself. So keep that in mind. Think of it as pi times r, not r times 2. And what is the radius in this circle, Addison? 3. Cut it in half because they're giving us the diameter. So we will use half of that. And then Addison, pi times 3 squared gives us what as our final answer? 28.26, and that's going to be inches squared because it's area, not perimeter or circumference this time. Okay, good job. Remember, she's doing pi times 9, not pi times 6. Okay, number 24. Find the value of x in these two angles. Now, what do you call, we just did, this is recent. What do you call two angles that open up on opposite sides of each other when two lines cross, Jude? They are called vertical angles. That is absolutely right. And what is true about vertical angles other than they're just opposite from each other? They're the same. That tells you this angle here is 46. Now, that doesn't mean x is 46. It just means that angle there is 46. So I can set x plus 5 equal to 46 because I know that's what it ultimately will be. And if x plus 5 equals 46, what does that make x equal to, Natalie? 41. Subtract 5 from both sides, and x has to be 41. And double check your work. That makes sense. 41 plus 5 gives you the 46 degrees that you needed it to be. Number 25. Number 25, what do you call two angles that form a right angle? All right, scratch that. How big is a right angle? How many degrees? 90. What do you call two angles that add to 90? Complementary. That's right. What do you call two angles that add to 180? Supplementary. That would be a straight line. That's not what we have here. We have a right angle. So they're going to add to 90. So 8x minus 6, that little sliver of an angle, plus the 80-degree angle has to equal 90 degrees. Or you could have actually said, since you know it adds to 90, if that's 80, what's that little sliver measure? 10. You could have just said 8x minus 6 equals 10. And that's what you get if you just subtracted 80 from both sides to start out with. Okay, so but we'll just use this as a starting point because it's still true. That little sliver is 10 degrees. Add 6 to both sides. 8x equals to what? 16. Okay, divide by 8. X is equal to 2. So x equals 2. That little sliver equals 10. The whole thing equals 90. But again, x has to equal 2. Save and exit, don't submit. Hang on to your work papers for a couple more days. We are caught up, but we still have some more catching up to do. But I see a lot of quick problems that we can do here coming up, especially look how easy these are gonna be. Turning 23% to a decimal, turning 0.79 into a decimal percent. Those will be pretty easy coming up. So we'll catch up tomorrow. 1 second.